Hello everyone. So in this deeper dive video, again, I wanted to give you sort of a preview of what you would expect to learn in Algebra 1, where we solve, again, more complex algebraic equations, which require more than one step to solve for the unknown variable. But in this case, they're going to involve sign numbers, right? Positive and negative numbers. So let's start off immediately with an example. Let's say I want to solve this equation. So 25 minus 3c is equal to 34. Okay, so this is my equation, right? And now my variable is c, so I want to isolate the c. So what do I need to do first? Well, I can't directly isolate the c. I first need to start by isolating the negative 3c. And since I have a 25 added to the left-hand side, what I can do to get rid of that 25 is I can subtract it, right, from the left-hand side. But whatever I do to one side, I have to also do to the other side. So now 25 minus 25 is 0. So I'm just left with negative 3c on the left-hand side equals, and then 34 minus 25 is going to be 9. Okay, now how do I solve this for c? Well, I need to get 1c. But since c is being multiplied by negative 3, if I divide by negative 3, that'll give me a 1, right? Because negative 3 over negative 3 is positive 1, right? They would cancel. So we know how to divide by negative numbers now. We learned that in this module. So if I divide by negative 3, but whatever I do to one side, I have to do to the other side. So on the left-hand side, I get exactly what I want, right? So these cancel. You can say it's 1 over 1. So that leaves me with c. I've isolated the c. And then what's positive 9 divided by negative 3? Well, 9 over 3 is 3. And remember, positive divided by negative is negative. So this is going to be negative 3. So we're just solving algebraic equations just like before, but now they involve signs, right? Positive or negative. Okay, here's another example. Let's say I want to solve 5 minus 8x minus 2x is equal to negative 25. So I want to solve that equation for x. Well, first, remember we have to always combine like terms. If there's like terms on the left-hand side of the equation or the right-hand side of the equation, we have to combine them first. So these, the negative 8x and negative 2x, are like terms. So what I want to do is I'll start with negative 8x, and I want to subtract 2x. But remember, subtraction we can think of as addition, so I can write this as negative 8x plus a negative 2x. So how do we do this? Well, really all we need to do is we need to add a negative 8 and negative 2. So if you remember from this module, right, if I have the same sign, I add their absolute values. So 8 plus 2 is 10, and then I keep the sign. So negative 8 plus negative 2 is negative 10, and then I still have an x there, right? It doesn't quite work to say like negative 8 apples plus negative 2 apples is negative 10 apples, but essentially that's it. You need to keep that x there. So this equation becomes now 5. I've combined those to give me negative 10x equals negative 25. Okay, now I want to isolate the term containing the x, right? I want to isolate negative 10x. So how do I do that? First of all, when I say 5 minus 10x, I can really think of this as 5 plus a negative 10x equals negative 25. Remember, subtraction is the same as adding the opposite. So really the thing I'm isolating is the negative 10x. We don't usually actually do that step. We assume that that is what we're isolating, but that's why it works, because I can think of that as written as plus a negative 10x. Okay, so to isolate it, I need to first get rid of the 5. So how do I get rid of the 5? Well, I'm going to need to subtract 5, right? So that'll give me 0. These will be gone, but whatever I do to one side, I have to do to the other side. So here's where our knowledge of sign numbers comes in. What is negative 25 minus 5? Well, I can do that on the side here, right? If I have negative 25 minus 5, I can think of that as negative 25 plus the opposite of 5, right? And negative 25 plus negative 5 is negative 30. So this is negative 30. And then finally, I need to do just one more step to isolate the x. I want to get a 1x. since it's being multiplied by negative 10, let me divide both sides by negative 10. So these cancel. I get x equals, and then what's negative 10 or negative 30 divided by negative 10? Well, 30 divided by 10 is 3. And remember, a negative divided by negative is positive, right? If it's the same sign, it's positive. So this is going to be a positive 3. And that's my answer. So it should be x is equal to 3. Okay, let's do a few more examples. Now, I'm going to introduce one more property. Again, you'll learn a lot more about this in Algebra 1, but let me just mention it here. So one more property that we're going to need, it's called the distributive property. And what it says is if I have A times B plus C. So if I want to multiply that sum by a value A, then I can distribute it in. So basically what happens is you multiply the A times the B first. So this is going to be A times B plus, and then A times C. And those two things are equal. Here, I'll do an example. Let's say A is 5, B is 3, and C is 4. Then what this is saying is that this should be equal to A times B. So that would be 5 times 3 plus, and then A times C. So 5 times 4. Well, let's check it. Order of operations, right? So I need to do inside parentheses first. So this is 5 times 7, right? 3 plus 4 is 7. And that's equal to 35. And on the right-hand side, I need to do the multiplications first. So 5 times 3 is 15, plus 5 times 4 is 20. But now I can add them, right? That's my only operation left. What's 15 plus 20? That's 35. So those will always be equal. So that distributive property will always hold. Okay, why do we need that? Well, what if you have an example like this, an equation that you want to solve that looks like this? Let's say we want to solve negative 2 times x plus 6 is equal to 15. Okay, I want to solve that equation for x. Well, the first thing that you need to do is you need to multiply in at negative 2. We need to distribute in the negative 2. So here's where the distributive property comes in. Let me just write this again here. So I multiply negative 2 times x. Well, that I can just write as negative 2x. Right? Remember when I write the x next to it, it implies multiplication. And then what's negative 2 times positive 6? Well, from this module, we know that's going to be a negative 12, right? 2 times 6 is 12. A negative times positive is a negative 12. And now I can solve it like I normally would. How do I isolate the first I want to isolate negative 2x, so I can get rid of that negative 12 by adding 12. So I have negative 2x is equal to 27. And then finally, to get x by itself, since it's being multiplied by negative 2, I can divide by negative 2, right? Because I want a 1x. This now cancels, which is great, but whatever I do to one side, I have to remember to also do it to the other side. So my final answer is going to be x is equal to, well, 27 halves, I can't really simplify. I could write as a mixed number if I wanted to, but I'm going to leave it as an improper fraction. But the important thing is I have a positive divided by negative, which is negative, and then I can just leave this as 27 halves, right? So that would be my answer. So x is negative 27 halves. Okay, and then let's just do one more here. Let's say I want to solve this algebraic equation for t. So I have 3t minus 2 is equal to 4 times t minus 2. Okay, so again, first thing I want to do is I have to distribute in that 4 on the right-hand side. So using the distributive property, right, I can multiply 4 times t and then 4 times negative 2. So the left-hand side, nothing has changed, just leave it. 4 times t is 4t, and then positive 4 times negative 2 is negative 8. Okay, now I want to solve this for t. Here's something we haven't really talked about yet, right? In order to solve it for the variable has to be on just one side of the equation. So I either have to move the t's to the left-hand side or the right-hand side. It doesn't matter which side I go to. Let me just bring the t's to the left-hand side, the variable to the left-hand side. So I need to get rid of this 4t, right, in the right-hand side. How do I get rid of it? Well, if I subtract 4t, that will give me 0 there, right? So if I subtract 4t, that gives me 0, and I'm just left with the negative 8. But I can't just subtract it from one side. If whatever I do to one side, I also have to do to the other side. Okay, so on the left-hand side now, I have 3t minus 4t. Well, remember, this is the same as 3t plus a negative 4t. Well, what's 3 plus a negative 4? We spent a lot of time, right, looking at these types of problems in this module. Remember, that's negative 1, right? 3 plus negative 4 is negative 1. So this is negative 1t, which, by the way, you could just write as negative t. You don't have to write the 1 there. But just to emphasize it, I'll leave the 1 there. So negative 1t minus 2 is equal to, remember, these are gone by design, and then this is negative 8. And then I want to solve for t, right? So I need to get rid of that negative 2 now. So how do I get rid of that? Well, I add 2 to both sides. So I have negative 1t is equal to, what's negative 8 plus 2? That's negative 6. And then finally, to get t by itself, it's being multiplied by negative 1. So I'm going to divide by negative 1. Right? So these will cancel, and I'll get 1t, which is t. But whatever I do to one side, I have to do the other side. So that's also divided by negative 1. So on the right-hand side, I have negative 6 divided by negative 1. Well, 6 divided by 1 is 6, and negative divided by negative, right? If it's the same sign, remember the answer is positive. So this is just going to be a 6, right? Negative 6 divided by negative 1 is positive 6. So that's my solution. So t is equal to 6. And you could always check it by going back to the original equation, and where you have a t here, you could plug in a 6 here, and you're going to find that you get the same result on both sides. Actually, we can do it quickly, right? This is going to be 18 minus 2, which is 16. Here, 6 minus 2 is 4, so I have 4 times 4, which is 16. So that checks, right? So the correct solution is t is equal to 6. That is correct. All right, again, I just, don't worry about these types of problems for this course, but if you're interested, I just wanted to give you sort of a preview of the type of stuff you would see in Algebra 1. Thanks.